Trig. Most is going to be trig, okay, when it comes to this one. And I need you to be able to identify which law to use right off the bat. I will do this one, and then if there's some space left over, I will give you a short little cheat to always know which one are you going to use, okay? Geometry and trigonometry. The construction company needs to calculate the length of support wires required to install an antenna on a roof. Calculate, this is hint for it's not just going to be easy, right? You're going to have to use some sort of formula. Calculate the length of the shorter support wire. So we look at this scenario. We're asked to solve for this here, and it's very cluttered. So I'm going to sketch that somewhere else. I'm going to maybe do that here. I'm going to copy this one out like this, and then like this. Let's do that, okay? This is 10 feet. This is X, that's what they want. The 50 is right here, that angle, and this is 20. What law am I going to use to figure that one out? Cosine law, that's right, because it's side angle side. And side angle side, right, you've got two sides and the angle in between. So it's cosine law. Did you know that just by selecting the correct law, you already get 1 mark? It could be everything else could be wrong. If you select cosine law, you get 1 mark. So let's do this. So to find X, we go X squared. It's 20 squared. And I want you to use your calculators on this one, because when I was marking your reviews, I noticed some of you your work was perfect. Like you actually wrote it down exactly what I was expecting. But then this part, the part that goes into the root, that was off. So the first thing I want you to check before you start your exam is your calculator set to degrees? Some of yours can easily be changed to a different gradients or radians. You don't want that. So let's go ahead and type this in. 20 squared plus 10 squared minus 2 times 20 times 10. All in one shot, try it. You should get this. 242.884, and that goes on. I would use all decimals to make sure I get it right. And then take the root of that, and that's 15.58. That's what you should be getting, 15.58, and we are in feet. And there you have it. You got it? So you would get 1 mark, basically 1 mark for this, then 1 mark for the correct. Oh, only get 2 marks for this. Never mind. Like that. So 1 mark for the indication that you're using cosine law and 1 mark for the work. That has slightly changed since 2015. This would usually be worth 3 marks. Usually. Okay. I will just say this. On this page, maybe, if you have a triangle and you have like 5 and 47 and 7, right? This is SAS, cosine law. And it's going to, right, if this is your missing side, it will be x squared equals da, 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 da. If you have a triangle where it's like 5, 7, 8, something like that, the only choice you have is to solve for an angle. This is side, 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 which is also cosine law. And for this one, you're going to have to use, if you want to solve for this angle, your formula will start like this: cosine of A right? You add and subtract, and this number here has to be across the angle you're wanting, so 8 squared. That's all I'm going to say there. You might already have this down, so you don't have to worry about it, but I thought I'd just quickly review that one more time. Okay, next. This question right here is no longer on an exam. They used to want you to have real life examples where, with, for example, sine law is often used in construction. Sketch and label a picture that demonstrate where sine law can be used in the real world. Yeah. So what do you need? What needs to happen for you to be able to use sine law? What do you need in the triangle? A pair. So in this scenario, I tell students, come up with something where you get a pair, right? So let's say you're building a roof. This is a roof, and this is 20 feet. Oops, 20 feet. This is 65 degrees. And maybe you just say this span down here is 35 feet. Determine this angle, right? So you're building a roof, you have a pair, and you're trying to find the angle at the top. So I'm not going to spend a whole lot of time here, but that's what, so this type, they no longer have this. So I'm just going to skip it, and we're going to move on here. You could have had, you know, an airplane up there looking down at two objects, and you just fill in the numbers, you name it. Okay. Next, a regular polygon has central angles of 45 degrees. State the number of sides for this polygon. What do we know? When it's regular, we know that all sides, all angles are the same, correct? Let's state that here to remind ourselves. All sides are congruent. All angles are congruent. That's what that statement is saying. Polygons. So a regular polygon has a central angle of 45 degrees. So what the question is saying is that C is 45 degrees. State the number of sides of this polygon. They're asking, hey, how many sides does that have? This is what? Backwards. This is a backwards example. Now, if you don't have that on your study sheet, you should recognize central angle. Maybe go to your formula sheet, and it's like central angle is, this is the formula. So I'm going to go central is 360 over n, 360 degrees that is. We plug this in for C, so we go 45 is equal to 360 over n. We put the 1 there, cross multiply and divide. So it's 360 times 1 divided by 45. That's 8. 8 sides. Boom. State the name of this polygon. So what is this polygon called? Octagon. Yes. 1 mark for that. I know they've done hexagon like this. They've done octagon, pentagon probably. I haven't seen the other ones, but what's a 10-sided? Decagon, yes. And then there's nonagon for 9, hepta for 7, hexa 6, right? 23. Oh, multiple choice. Choose the letter that best completes the statement below. The following triangle is a isosceles, yes. So you can circle and just write down C. I would do both just to make sure. Okay, keep going. Sketch a rhombus and label all congruent parts. All, what does it say? All things that are equal. So let's do this. 2 marks for it. Do you know what a rhombus looks like? I hope so. It's a slanted square. These are the same. We know that this angle will be the same as this one, and that this angle will be the same as that one. That's, I think, good enough. It's gonna see, yeah, that's good. Right, that's 2 marks. Let's keep going. There's another. Polygons are often used in construction, commercial, industrial applications. Sketch a picture or diagram that demonstrates how properties of polygons are used in real world. Support your diagram with an explanation. Okay, I'm just going to give you a quick example. One would be if you build a room and you want to make sure you want to make sure that these are 90s at the corners. You would measure and make sure that the diagonals, right, are the same. So if this is A, B, C, D, you would have to make sure that AC, like this stretch, has to be equal to DB, right? Like you actually measure across the room, and that will ensure that you have square, like 90-degree angles at the corners. Okay. So I'm just gonna keep going because those questions are no longer on the exams. A building is on the side of a hill. Calculate, so work, right? The length of the shadow X the building will cast on the ground. So they're asking for this. What law are you going to use here? Sine Y. Yes. Yes, yes, yes. This is very obvious. This is not the hidden pair. Beware of the hidden pair. Right? There's a pair, sine law, but you have to use it correctly. So let's see here. I would go sine of 75 degrees. Obviously goes with 30 feet. And I already have the angle that's going to allow me to solve for that side. So perfect. It could have been that they gave you this angle in this corner, right? In which case you would have had to use sum of 180 to get this angle, which then allows you to solve for this side. So I'm just preparing you mentally for various scenarios, right? Okay, cross multiply and divide. So we go 30 times sine of 50, morning, divided by sine of 75. Calculate that, make sure your calculator doesn't act up funny here. 30 times sine 50 divided by sine of 75. I get 2379. And we are in feet. Don't forget your units. You're solving for a side, so it has to be feet. If it's solving for an angle, make sure you have degrees. All right. Keep going. Oh, I'm going to stop this and start a new one.